Over the next number of video lectures, we're going to get ourselves back into some trigonometry. In this video, we're going to talk about the basic trigonometric identities. Our objective, we want to define the 8 basic trigonometric identities. Well, let's start out as usual with what we know that's going to be applicable. And we know that if we have a right triangle and we have one of its acute angles, we call the side that is opposite the acute angle the opposite side, and we call the side that is next to the acute angle the adjacent side. And of course, the longest side of any right triangle is called the hypotenuse. The longest side, of course, is directly opposite the largest angle. So just a quick sketch. I'll draw a rather simple right triangle. There's my right angle. The side opposite the right angle is the hypotenuse. And again, the right angle is the largest angle, and the side opposite the largest angle is the longest side. If I have my theta, my angle indicated here, one of my acute angles, if I indicate this is theta, the side that is opposite the acute angle, the indicated acute angle, is we just simply call the opposite side. And the side that is next to this acute angle, this is obviously not the hypotenuse, we call this the adjacent side. Adjacent, of course, meaning next to. And we also know that we have 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. The sine is the ratio of the opposite side length divided by the hypotenuse. The cosine is the ratio of the adjacent side length divided by the hypotenuse. And the tangent of the angle is the ratio of the opposite side length divided by the adjacent side length. Continuing, cosecant, hypotenuse over opposite, secant, hypotenuse over adjacent, and cotangent, adjacent over hypotenuse. Okay, let's get into our objective here. We want to talk about these trigonometric identities, but first let's define what an identity is in mathematics. An identity is an equation that is true no matter what values are chosen. So the left side equals the right side, no matter what you have for values. Of course, we want to keep in mind that we're not going to be dividing by 0 and stuff like that. Okay, so the 8 basic trig identities. We'll start with the fact that if we look up here, we'll notice that these pairs, and I have them sine paired with cosecant, cosine paired with secant, and tangent paired with cotangent. So these pairs are reciprocals. The sine is the opposite over the hypotenuse. 1 over that is the hypotenuse over the opposite, called the cosecant. The cosine, similarly, is the adjacent over the hypotenuse. 1 over that, 1 over the cosine, is the hypotenuse over the adjacent, which is called the secant. And the same thing holds for tangent and cotangent. So this leads us to the first 6 basic trig identities. I'm going to prove number 1 briefly. The sine of an angle is equal to 1 over the cosecant of the angle. And so no matter what the angle is, this is an identity, no matter what the angle is, this is true. The sine of 45 degrees is equal to 1 over the cosecant of 45 degrees. So here's our proof, and I'll just prove this one. The others follow similarly. Okay, we know that the sine is equal to the opposite over the hypotenuse. That is right here. We can rewrite that as 1 over the hypotenuse over the opposite. Okay, it may be easier to go this direction. 1 divided by the hypotenuse over the opposite is equal to the opposite over the hypotenuse. So we can go this direction. The opposite divided by the hypotenuse equals 1 over the hypotenuse divided by the opposite. Well, here, the hypotenuse divided by the opposite is the cosecant. So this is equal to 1 over the cosecant. I guess I should write that down since I wrote down sine. So this is 1 over the cosecant. And that's the proof of the first one. Okay, and continuing, we can do all those the same, but I'm going to go ahead and just write down the first 6. The cosine of an angle is equal to the reciprocal 1 over the secant of the angle. The tangent of the angle is equal to 1 over the cotangent of the angle. And continuing on with number 4, 5, and 6, we'll just go the reverse direction. We'll now define these in terms of the reciprocals of these. So the cosecant, of course, if the sine of the angle is equal to 1 over the cosecant, then the cosecant equals 1 over the sine. And same thing here, if the cosine is 1 over the secant, then the secant of the angle is 1 over the cosine. And finally, if the tangent is 1 over the cotangent, then the cotangent of an angle is 1 over the tangent. So those are your first 6 definitions that are essentially stating that the reciprocals, the sine of an angle is equal to its reciprocal, or 1 over. Is equal to, 1 over its reciprocal. So the sine is equal to 1 over the cosecant, etc. Those are your first 6. Now, let's look at 2 additional identities. So I'll turn the page over here. Now, we can also divide sine by cosine and divide cosine by sine, and this leads us to the other 2 basic trig identities. So let's take a look. Let's take the sine divided by the cosine, the sine of theta divided by the cosine. Let me get my notes together here. Well, the sine, of course, as we know, is the opposite divided by the hypotenuse, and the cosine is the adjacent divided by the hypotenuse, as per our definition. So opposite divided by hypotenuse, all of that divided by adjacent divided by hypotenuse. When we're dividing fractions, or when we're dividing, we're multiplying by the reciprocal. So I can rewrite this as opposite over hypotenuse times hypotenuse over adjacent. Again, division is multiplication by the reciprocal. You can see here that we have hypotenuse, and hypotenuse is a common factor. And so this will tell us that this is equal to opposite over adjacent. And we know that opposite over adjacent is the definition of the tangent function. So the sine divided by the cosine is equal to the tangent. And similarly, that's a hard word for me to say, the cosine of an angle divided by the sine of an angle. Well, cosine is, by definition, the adjacent over the hypotenuse. Sine, by definition, is the opposite over the hypotenuse. We'll do the same thing. I'm going to rewrite this division problem as a multiplication problem. Division can be rewritten as multiplication by the reciprocal. So I'll keep the first term, adjacent over hypotenuse. I'll multiply it by the reciprocal of the denominator, hypotenuse over opposite. Again, you'll notice the common factor of the hypotenuse. I'm left with the adjacent divided by the opposite, the adjacent length divided by the opposite length, and by definition, that is the cotangent. Okay, so there you have it. I have listed here the 8 basic trig identities. These are, I guess I could say, they're the reciprocal identities. And this is taking a look at sine and excuse me, try again. This is taking a look at the tangent and the cotangent and speaking to them in terms of sines and cosines. We're going to make use of these quite a bit as we go through the rest of some of these trigonometry lectures.